Can I have my clicker, please? Thank you so much. So we already got an introduction. Please all tab over to our presentation.
Yeah.
You went too far.
Yeah.
So
I always
tonight's talk is kind of what we are doing every couple years, is kind of giving an overview of what happened in the past few years with ILSpy and diving into a specific topic. And because obviously one of the cooler new features in the latest C# version was extension everything, we thought, okay, we'd pick something that is rather recent to give you an idea how actually the stuff that you're using day to day in Visual Studio, Writer, whatever, how you're using C#. So you get an understanding what the C# compiler does on your behalf, what happens under the hood, how the lowering works, and kind of how we get back actual proper C# code for you. So who are we? You actually got 2/3 of the core maintainer team of ILSpy here on stage today. So Sigi and myself here, both of us are actually from Upper Austria. So the most well-known open source decompiler is partially written in Austria, actually. And we are being used in Visual Studio, so most everybody is actually using our decompilation engine these days. So where can you find us? Unsurprisingly, we are not on the big X anymore. We have two presences online. One on Blue Sky is basically marketing, where we give information about what's coming, what's new. And if you're really interested in kind of the internals of what our team is working on doing stuff like this, you need to go to Hackyderm. That's where we are posting all the internal stuff that is currently happening in ILSpy. So that would be that. And by the way, we already posted the slide deck to the notes for tonight's meetup. So you can already get the slide deck. So if there's a link in there that's interesting to you, you don't need to take a photo. You can actually download the PDF slides and use the links from there immediately. So how is the talk usually structured? That's me talking about generic stuff, like what are our biggest failures? And is there something that you can learn from our biggest failures? And then obviously, what are we going to fail on next? So future predictions, because that usually happens in that case. And then we're doing, as I said, one thing under the hood, and that's why kind of I do the overview stuff and that the technical deep dive is done by Sigi. If you're interested, we did one of those things like in 2022 in Vienna. So you can have a look at what kind of challenges we solved last time around, because last time around was also quite interesting. So what did we talk about last time around? And I like starting with the biggest fail of all times. That was the yield bang bang operator. So that was basically automatic null checks. Microsoft announced the automatic null checks. We thought, cool stuff, let's implement that. Yeah, and then you can see the timeline. Added on 16th of April, disabled on 19th, because Microsoft backed it out immediately. And then we removed the feature entirely 2 years later. So basically, work spent on something that never made it into the product, was removed immediately, more or less. So that is kind of the poster child of stuff for us moving too fast. And yes, I'm going to get back because we moved too fast again. So last time, the part was moving from net full 7.2 to net 6.0. Today, we are actually already net 10 and doing the first tests with net 11 as well. We were kind of doing a deep dive into our test runner because our unit testing is slightly different from your average enterprise application unit testing. So if you're interested in strange testing stuff, then that's for you. One thing that we kind of did big time last time was ILSpy X, our cross-platform catch-all project, where basically everything lives that is not the decompiler and not WPF-specific Windows code. So the intent was and still is provide most of the UI services in a manner that can be used on all platforms. So the use case back then was Avalonia ILSpy, which I'm going to get back to, and as well the VS Code extension that is using all those services as well. That's available for Linux, Mac, and etc. And obviously, security, I'm very much interested in security. We are going to get back to security in a second. So what has happened since 2022? a couple of releases. So yeah, we don't have a predictable release schedule. We never commit to a date because we never hit it. We are a classical open source project. We are doing it in our spare time, and that means if life intervenes, that means weeks of no activity potentially. So any dates we would plan for, well, we never made it. So, but there's pretty much going on. We are currently on preview 2 of the version 10. There will be just a little bit more sugar added before we are releasing, and then that's that. So I thought I'd bring a couple of stuff that we kind of failed on. We have a Visual Studio extension, and we were creating also ARM64 releases for ILSpy. And then we found out, hey, we made a slight mistake when we released the Visual Studio extension, because the Visual Studio extension ships with the full binaries of ILSpy. And we forgot to include the ARM64 binaries. So we had to fix that actually those binaries are then included properly, as well as the x64 binaries. So, oopsie. And that is our most useful bug that we ever had. Guess what? .NET 10. How many digits are in the number 10? 2. Guess what? We made a check for .NET Core that it's a single digit. So up to version 9 of .NET, everything was hunky-dory, working perfectly fine, but then .NET 10 first alpha came around, and obviously first thing was a Microsoftie testing ILSpy with the first alpha of .NET 10, and was like, doesn't work. On the upside, we never before were included in Roslyn at the latest version as quickly as in that case, because they wanted a working version of the decompiler in Roslyn, so they immediately included the version that had the bug fix. So it was a happy bug in that respect. Now, security, as I said, is important for us because we are included in all over the places, and we keep kind of improving all the time the security. So if you haven't heard of the OpenSSF scorecard, that is something to start looking into, because it gives you a couple of improvement hints how you can step up security in your processes. That ranges from build automation like reproducible builds, branch protection, which is, we had like discussed it twice or even more often whether we are going to do it. We are not doing that at the moment, but you get an idea what the stuff is, and more or less, if you take a look at NuGet, you get links, and you can link off to the OpenSSF scorecard. You can see that most of the .NET NuGets are somewhere in the 5-ish range. There's very few ones that actually go up to 7, as we are now. So security recommendation, if you're publishing NuGets in your org, or even publicly, that is something to consider. Including in that is a new NuGet package for SBOMs. It wasn't such a big topic in Europe, but it was one hell of a topic in the US, that basically you need to have SBOMs from all the vendor dependencies that are being used in your software packages. And using that SBOM target basically takes all the work out of it and includes the SBOM manifest into your NuGet packages. So also kind of highly recommended that you start looking into this. That was kind of stuff that we did for security, and then obviously the past 2 years, there were a couple of hiccups in the continuum, I would say, in open source. A couple of libraries going closed source, and one of those that hit us was fluent assertions. And at first we thought, okay, not a problem. We are simply going to lock down the version, or even we could upgrade, because it would have been possible for an open source project to actually go ahead and do the upgrade. But then we started thinking, wait a second, that's a problem. We need to switch away, and why on earth would we need to switch away? So we are MIT licensed, which means it's perfectly okay for somebody else to take the source code internal and start building for their own specialized product. And if we had fluent assertions in the latest version in there, then immediately the for-pay option would have been active for them. And we wanted to avoid that somebody taking our source code would inadvertently be in violation of the license of something that we are using. So that's kind of why we switched away. And bonus information, if you have that problem, use awesome assertions. that library we are using now in our internal products, which is not open source. That is basically what I would be recommending these days. Shootly doesn't have enough activity. Awesome Assertions is the place to go these days when you need to do something in that respect. So, a self-inflicted pain. Kind of the story how ILSpy started. That was back in the day with .NET Reflector, and then it being sold, and then you needed to pay for it. And that was kind of, yeah, OSS drama back in 2011, more or less, but it was only free software at that point. And then we were back then doing still our IDE stuff, and one of our colleagues came around and said, oh, you know, I did a decompiler for my PhD, and we were like, and when did you plan on telling us that you were doing a decompiler for your PhD? So we took his code and over a weekend, more or less, turned it into an application. And it still shows in our code base that it was kludged together over a weekend. That means best practices, yes, we've heard of best practices, especially when it comes to MVVM and stuff like this. So tech debt, that was kind of the definition of it. So there's really a ton of pull requests by Tom Englert. But obviously, if you're changing that much, guess what? Some behavior falls on the floor. Behavior that was there before and you overlooked in the pull requests when you were looking at, because you forgot that a specific way of writing stuff was intended to be a feature. So we were then going through, oh, wait a second, oh, that no longer behaves as it used to behave. We need to fix it. So that was a lot of self-inflicted pain and swearing and stuff like this. Yeah, that is something I don't recommend. One thing that I do recommend, though, is going looking for the Microsoft testing platform. Funny story, we started out early on, and then the Microsoft team came around because Yusuf is a member of the Microsoft team, because in the last RC, more or less, they changed how to activate the Microsoft testing platform. They had a .NET config file, and they moved the configuration to enable Microsoft testing platform to global JSON, which was kind of fun to do at the last moment to make that change. And that kind of triggered me then, yeah, global JSON is a thing again, because usually you wouldn't really strictly need it. Now, if you're moving over to Microsoft testing platform, it's needed. Why is Microsoft testing platform a very good idea? The test runner is included into your test assembly, and that means your tests run on the target.NET runtime. Mobile, whatever, it's running on the target runtime, which is a nice addition because the normal .NET test wouldn't be doing that. Also, a new thing in .NET 10 that maybe no one ever needs to know anything about unless you're listing files from disk. Because .NET never had the capability to actually order file names the same way as Windows Explorer does. So we were using natural sort extensions. Obviously, Sigi immediately stepped on the landmine that was in there because, yeah, all of that crap here is actually proper numbers that should be sorted by number and not Unicode position. And there is a Windows API. We have been using the Windows API for ages, but we needed to move away from the Windows API, so we ended up with natural sort extensions doing that stuff. And here, basically, that's now the change that is possible with .NET 10, that you can actually do proper numeric ordering. One of the coolest features, and one dependency gone from the project. Yeah. A topic we really ignored for a long time. We actually, and I'm going to come back to AI, we actually tried to add a translation using AI, which worked okay-ish. And then we were like, yeah, now we can do the translations. Wait a second. We have zero way when somebody opens a pull request and provides a translation to make sure that actually it's a proper translation and not anything improper in there, whatever improper is in terms of definition. It would be impossible for us to validate. So we had a ton of technical reasons, but basically we went back and said, yeah, there are no plans to provide translations in the future anymore, simply because it's impossible to validate. And it made kind of including the stuff horrendously complex. So we decided it's a developer tool. English has to be good enough. That was kind of a decision where we kind of said, yeah, because otherwise we're getting tons of pull requests from people that also wisened up that they could be using Copilot to create the translations. And we then would be like, yeah, there's no way we can validate what's in there. Let's not get into a bind by doing that. Smaller fish, yeah, because that's an ARM64 laptop. I took out some time to actually make tests work and compile on ARM64, given that we basically have complex tests. That means we're taking source code, compiling the source code, decompiling the source code, recompiling it again, and comparing the initial code to the decompiled stuff. So there's a lot of things going on, and obviously taking all the native compiler toolchain and stuff. So it was a kind of an interesting thing to get that off the ground. And yes, although the machine with ARM64 code is great, our tests really bring it to its knees. So don't develop ILSpy using an ARM64 laptop. That's kind of the message, although they are quite good at that. One thing that might be interesting to every one of you, somebody came along and said, I only have .NET 9 on my machine. That was ILSpy 9 basically. But I said, I have only 9 on my machine, but you are a .NET 8.0 compiled tool. How about you adding that nice feature roll forward that automatically means, hey, if a newer runtime is on the machine, use the newer runtime that is on the machine, even if the one that was targeted is not there. So that is kind of a cool thing that I had no idea and I wouldn't have known unless I was on the open source project. And that's just for shits and giggles on here because I said smaller fish. That's actually a big fish in terms of features. We had kind of special casing when we were adding new file types. Like, okay, you have a DLL. That's standard.NET. Oh, wait a second. You got a NuGet package. That's actually a zipped file with a file structure in there. Oh, we need to special case that. Oh, that is something for... what was it? Xamarin. Yeah. Yeah, Xamarin. That's compressed totally different. Oh, we need another way of doing that stuff. So if else, you basically imagine it like that. And then we added WebAssembly because Blazor allows the stuff to be repackaged in a WASM file, so we can unpack the WASM file properly. And then Sigi sat down and actually made an API that actually is capable of plugging stuff in and making the things happen. So that's kind of a thing. Getting back to open source is fun and interesting. Who here knows Avalonia? That's a cross-platform UI library. And for one, you can target Avalonia. So we had Avalonia ILSpy, which basically was taking our source code at a certain time and taking the WPF code, throwing it out, adding Avalonia controls, basically redoing the entire thing. That's how ILSpy X started, so that more stuff is reusable without having to replace everything. What they also have is the XPF framework, which is basically take your existing WPF application, add the XPF library, recompile, and you automatically get binaries from Mac and Linux, and still using your existing WPF code. That is what actually the Avalonia guys did as a proof of concept, taking the stuff. So that is also where the natural sort stuff comes from, because we had DLL imports all over the place. So we were stripping out all the platform-dependent stuff so that could get off the ground. So that was an interesting experience for us in learning what it takes to take a Windows application that no one ever really thought about porting to another platform and actually making it sort of portable. But that really didn't take off because obviously XPF is a commercial library. You can't really use that properly in an open source application. So that was basically a nice experience for us to make our stuff a lot more portable, but then it fell flat on its face. Then we archived Avalonia ILSpy because for a couple of years we weren't able to find a new maintainer. Then we took the decision, okay, if it's unmaintained, it's pointless. So let's better tell all the users that it's lagging way behind, let's shut it down. But not too long after that, we shelved it and thought like, okay, cross-platform efforts gone. Lex came around and actually started Project Rover, where he kind of started again, where we still have an open pull request basically to make it more palatable for WPF and Avalonia, our code base basically. And it's now quite advanced. You get now more or less ILSpy for Mac and Linux given his port. And we are currently still talking about actually really turning that stuff into the main UI for ILSpy 11. So we're currently in the 10 train, and the end of the 10 train, we're thinking about actually going with Avalonia UI in the 11 version, mostly because if Microsoft goes through with their AI plans, the core team will abandon Windows. And then we need a UI that works on other platforms as well. So one already threatened to move to Linux. So that is something that is in the cards for us. Now, speaking of AI, nice intro here. It's not something that we are not doing. It's something we have been experimenting for a couple of years in terms of where is AI actually useful, where could we be using it. So very early on, I did a test to say, okay, let's decompile the crap and immediately shove it into ChatGPT and do an explain this code. Would that actually make any sense? Back in the day, it was a childish explanation that line by line explained something which was pointless, so we shelved that. Then we thought, okay, writing the release notes is painful. Let's point ChatGPT to our commit history and let it write up the release notes. Oh, that was a spectacular failure as well, because it was hallucinating crap together. Like, I don't remember exactly what it was, but it was basically mixing up the performance improvements that were in .NET for terminal server sessions together with a totally non-WPF feature. And so, yeah, we started from scratch. So that was not a winner as well. Then what you already saw, we tried the translations, which actually works quite nicely. So that is really good. Then we, for shits and giggles, started, okay, here's the job, write the code. Given that there isn't too much decompiler open source out there that it could have learned from, it only basically learned our code base, more or less. So telling it to do something new without anything that it was able to learn beforehand, yeah, that's not such a great thing. We were using Copilot for PR reviews. For box standard scenarios, it finds a lot of interesting things. Sometimes it misses, obviously, but that's not too bad at all. So Copilot PR reviews, not that bad. And then a funny thing, we have been having, well, I was triggering MCP discussions inside because we thought, okay, wouldn't it be cool if you take the VS Code extension that's written in TypeScript anyways, deployed in VS Code anyways, let's take on an MCP server. Wouldn't that be a cool thing? And then come along an article in June last year where somebody had a brilliant idea. They were using the Docker image of ILSpy command, decompiling the entire thing in one go, and then having more or less an agent MD file telling it, okay, that's how a vulnerability looks like, and go hunting in that directory for this sort of vulnerability. So basically, what was like calling a stock route last week for security companies was already hiding in plain sight last June. And we were aware of that because of tool calling. And we were like, yeah, an MCP server for ILSpy doesn't make any sense because that's without context. And this is when that guy came around, C# by MCP, which is basically a standalone version of the Visual Studio solution engine, more or less. Like, it loads the stuff with Roslyn and then allows to navigate into the decompiled source code as well. So think of it, if you're using that, you can actually go ahead and use that as a data store or data retrieval solution to build an independent style application, where you can say, hey, here's the structure, map out the dependencies in my code base. That's exactly what you can start building with this guy here. And one thing we started out just recently, having a look at, okay, we have a decompilation result. Go ahead and find the stuff that we are missing to decompile properly. So there are use cases, mixed ones, that work well, some that don't work well, some that might be working way better now than they did when we started. So it's basically always re-evaluate what you found out and have a look at it later on again. Now, you don't need AI to get stuck for days. You can only ask Microsoft to do a minor version upgrade of Roslyn. So usually when we sit down in summer for our developer days, the intent is, for 3 days, to either do a refactoring of a specific part of the code base or implement new language features. And we thought, okay, Microsoft just released a new minor version of Roslyn. Let's fix that up first and then do the stuff. Yeah, 3 days later. Because they made so many changes to how the Roslyn compiler was actually lowering C# stuff that we had to get started on that one. So that was also a surprise. Now, I promised to come back to moving too early. We obviously started last summer with the Roslyn 5 and C# 14. But Microsoft had decided to only have it on the transport feed. So actually, we were able to use it in .NET Lab, which is going to be demoed by Sigi next. But the NuGet packages were missing for us. And because there were collisions between the public NuGet feed, which we needed for other parts of our builds, we couldn't actually move to that stuff. So that was kind of interesting limbo for a couple of months before we actually could go and add that to our code. We had to actually go asking Microsoft, where actually are the NuGets? Could we please have them on the public feed? And yeah, that happens some of the times if you are moving too early and implementing features too early. And you can see a couple months later, we actually were able to go Roslyn 5 in there. Now, will we move too fast again? Yeah, most likely. But let's start with the more down-to-earth stuff. We have a pull request. How long is it open? A year?
Yes.
A year, okay.
I think so, yeah.
To move to a new abstract syntax tree. So we want to improve. It's just a question of when we will get around to doing that. But the thing that we can promise is that the main focus these days is actually on language features. So stuff that is in C# 14, or even coming in C# 15, that is unions, discriminated unions, that hopefully should be shipping in one of the next few previews of .NET 11. And preview 1 already had runtime async in it. It looks ugly in ILSpy, but it at least doesn't crash the show. So most likely, .NET 11 is a good candidate where we're going to move too early again. And extension everything was one of those cases where we moved too early. First, the Roslyn 5 that I already told you about. Then, interestingly enough, Microsoft was shipping extension everything in the Roslyn 4 branch as well. But it was kind of generating different code under the hood. So we have a version 1 and a version 2 of the extension everything in there. And we forgot to actually implement the call sites, which have a couple of interesting things. And with that, I hand over to Sigi to tell you exactly where those things are buried and hidden.
Yeah, so on the first slide, you can actually see, okay, that's how extensions look like. I only omitted the static class container that's still necessary, but it's necessary for a good reason. And okay, before I go into the details, yeah, I'll give a quick overview. So the new extension block syntax is usable in the static class. So like the classic extension methods, the extension methods and extension members can only be defined in static class containers. And of course, the extension block basically solves the weird syntax problem. Okay, where do you put this argument in a property? So basically, okay, I've heard people don't like it. I was skeptical at first too, and yeah, it looks weird. It's one more level of indentation, okay, but I think it solves the problem, and it even supports generics, and yeah, so I think it's the best they could do. Yeah, and so the whole thing is basically fully backwards compatible. So the classic extension methods don't go away. You can basically still write extension methods like that. And in binary, it will basically work the same. And also all members are accessible via the method call syntax. So receiver parameters is basically, that's the thing I show. Yeah, the receiver parameter is basically the parameter thing at the top of the extension block. It's called receiver, and yeah, you can use any parameter modifier that was valid previously with in the classic extension method syntax. And of course, the receiver parameter is also, the name is optional. So you can, if you only want static extension methods, then you can, or yeah, properties, you can just leave out the name and it's fine. Okay, so here is a more detailed example. The first thing is we have a property you've already seen. The second is a static property. Yeah, static property, and then we have an operator. Operators, extension operators is an interesting feature, and yeah, you can do some nice, really. I think it opens many use cases now that you can actually really, mess around with stuff a bit. Yeah, and also in the bottom we have the new syntax for instance extension methods. So a little quiz for you. What does this code do? Does it A, print and does the compiler issue a warning or an error? B, does it print test hello world? C, does it print hijacked? Or does it D, do something else? Anybody? Anyone? No, it doesn't do C, and that's because, I'll come back to that later, but basically the designers of C#, they are smart people. They don't want you to mess around too much. Like you know, the problem with extensions is you just write using namespace, and then you get all the extension. It basically works the same as before. And there are open source projects or projects out there that put stuff into the system namespace, which is like, yeah, I don't like it, but some people do that. And so basically operators and basically any member that's defined as extension has lower priority than the actual defined operator or static method on the original type. So you cannot go around, make a NuGet package where you put weird methods and extensions into your project, and then people start, and you put that into the global namespace or system namespace, and it's imported by default, and people just wonder what is going on here. My project is broken. So that's a really smart decision to actually not allow basically overriding methods from existing types or like members from existing types via extensions. Yeah. So a quick overview of the limitations. In an extension block, you cannot put nested types, and they do not introduce a new scope. I'll explain that in more detail later. And extension blocks don't have a name, so that you cannot actually access them. That's the reason for the static container. So basically, if you need basically to, if you have two extension methods that have the same name, and you need to disambiguate, you can actually use the name of the static class to access the extension method or the extension property. Yeah, and you cannot add state, so there are no fields, so also no events, and so on and so forth. So properties really need to, you need to find something, some other place where to put your data, not in the extension. And of course, for the same reason as they don't allow overriding, that's my guess, for the same reason they don't allow overriding existing members, they also don't allow adding implicit or explicit conversion operators, because it's really hard to spot if something goes wrong. And of course, no constructors, but you can use static factor methods for that. One use case I borrowed from Dave, thanks a lot, is basically you can add domain-specific stuff to your, that's relevant to your application. You can actually make your application or your code, you can make it more nicer by just adding domain-specific stuff. Also, you can do that on any type. Another nice use case is polyfills. Polyfills are basically NuGet packages that you can put or add as a reference, so you get all the niceties of newer .NET versions, or if you want to use specific C# features, and you're still, like we are in the decompiler, on .NET Standard 2, then you cannot use many of the nice features. So you actually need to add all the nice attributes and compiler-generated types, and so on, and so or like predefined types. And you can do that via a polyfill library, and polyfills actually allow adding, via the new extension members, you can actually add more and more stuff. And many of the things in polyfills are basically already possible via extension methods, but properties and static methods actually allow more use cases. For example, just yesterday, I think I discovered that NUnit, they recently moved, or some versions, they moved away from their assert methods, and you had to do this predicate style of writing asserts in NUnit unit tests. And then they basically made a classic assert class that you can use, you can pull in via a NuGet package. And now they announced that they basically use now static extension methods to actually make it possible to be source level compatible. Basically, if you add the this new NuGet package, you can still use assert.method name, and it will internally use the classic assert definitions defined in the extensions. And of course, like I already explained, extensions do not cause conflicts. So if you basically move up to a newer version of .NET and you no longer need the polyfill, it doesn't cause any warnings or errors, because like I said, existing members are always considered first. The third use case I have in this presentation is enums on steroids. Basically, you can combine extensions and source generators to actually add methods and properties to enums. And you can even add static methods to enums. And that you can use to actually work around the fact that the methods defined for enums depend on reflection. So you basically you define, you add this attribute, and then the source generator generates it generates all the toString and is defined, and all the utility methods on enums can now be defined in a way that they don't use reflection, and you actually save a lot of runtime by doing that. Yeah. And a sneak peek on that's how extensions currently look on my extensions branch in the ILSpy UI. So basically, you can see we have the extensions class, and then below that we actually have a new node, and that's basically using the extension syntax in the tree view as well. And yeah, so it basically mimics the way that extensions are defined in syntax and actually hides away all the implementation details. Yeah. And yeah, what were stumbling blocks when we actually started implementing extensions or C#14 extensions in ILSpy? Of course, like Christoph already told you, we were moving too fast because we were actually using the wrong, an older version of the compiler when first looking at extensions. And so basically all the work we did was in vain because they basically changed how they model extension metadata or like extension member metadata in the IL. And another thing was like, is an extension block, is it a type or is it no type? And yeah, I had quite a few discussions with Christoph and also Daniel. And yeah, and generic parameters, they are weird. Yeah, I'll show you later what I mean by that. And of course, it took some extra work to actually fit extension members into the ILSpy UI, because usually we actually can use the existing types in the assembly and just show them like they are and just do some syntactic transformations on them. But this time, yeah, because of the encoding is strange, we had to jump through some hoops to actually get it right. Yeah, of course, like any good open source developer would do, I looked at another open source project, in this case Roslyn. What do they do when they basically, how did they model extensions in their type system? Turns out there is not much to see because it's just a few properties on the type definition in Roslyn. Yeah, so it's just nested types, and if you actually need something, if you basically, for an extension, for the implementation of an extension method, you want to find the definition, you actually have to do that yourself. You have to actually go through the tree of definitions and find it yourself. So yeah, that's what we had to implement at my daywork company. And now let's get into the down the rabbit hole into the implementation details of extensions. So where does our process start? So when we look at a new language version or a new language feature, we usually start at the C# lang repository in the language version history.md, because that basically shows all the features that have made it into the final version. So we take that as the first anchor. And then we take a look, okay, is there a spec for a feature? And sometimes reading the specification actually works out quite nice. sometimes not. Sometimes we actually have to dig into the Roslyn source code to actually find out, okay, what are they doing? Because I think, yeah, don't tell. Yeah, I think that those specifications, they are just suggestions, and the actual specification nowadays is the Roslyn compiler. So if you really want to know what's going on, you have to dig through the source code, and that's fine. I mean, it's harder, but yeah, it works. And also what we do is basically we then go to .NET Lab and we start trying out the feature. So first we look at the specification. What did they change? What's the new feature? How does the syntax work? And then we actually use the examples listed in the specification or in some blog post or any other article we use, and we try it out in .NET Lab. Previously, we used SharpLab. Yeah, and then we basically write out all the possible combinations of things you can do with that feature, and later we turn that into unit tests for our decompiler. So let's get started with a simple example. On the left, you can see I have prepared two extension methods. The one is using the old extension method syntax, and the print new is using the new extension method syntax. And yeah, on the right side, you can actually see the somewhat decompiled code.
Size.
Geht das mit Control?
Yeah. Better? Or still more? Yeah, you need to set the slider.
Is this fine now? So, yeah, we have the extension container, like I said. Then we have gibberish, more gibberish. And yeah, then we have something that looks like our extension method here. And then we have the old extension method. If you ever looked at extension methods in the past, at a lower level, you will know that extension methods basically have this extension marker. So it's clear that the first parameter is the receiver parameter. And as you can see, for whether you use the old syntax or the new syntax, it's still the same. The only thing that's basically new is that we have an extension group and an extension marker. And then we have this extension method. That's the marker method that basically describes, okay, what is the marker type, what is the receiver parameter, and every extension member has this attribute as well, so you know which marker type contains the definition of the receiver parameter. And as you can see from this generated code is that, like I said, extensions do not create a new scope. So you cannot basically, you cannot have two extension methods that have the same name in the same class, because they would be basically, the implementation of the method would still be in the top level scope of the class. The compiler-generated group type and marker type, they are not visible because you cannot use it. It's not. You can access it via reflection maybe, but it's not really usable. And yeah, this because there are basically two nested classes involved in the structure of the metadata of extensions. That's what made it hard to actually implement that in ILSpy, because we somehow need to remove one level now. And yeah. Okay, second example, I'll quickly show what do.
You need to bump the font again because
Yeah,
it doesn't.
of course, of course. Yeah, okay, like I said, we have an extension property, a static method, and an operator, and I'll go through the implementation details now, what it looks like. Yeah, we have again this group type and the marker type. If we had an extension method on integer, we would have a second marker type that's basically, that contains an extension method where the first parameter is int. And also you can basically define different names for the received parameter. So you would basically get multiple markers, and depending on what, in what group you put the extension member, you can basically reconstruct the structure where to put which extension member. You can reconstruct it from the metadata, and basically, yeah, that's where Microsoft basically moved stuff around, and we had to re-implement the decoding stage of the metadata. Yeah, and you see every method and property accessor throws a not supported exception, so you actually cannot do anything with that. But where does the code live? The code basically lives at the top level scope. So if you actually want to get the, so for the runtime, it's only, all the members are just methods. We have an extension method, we have the getter of the extension property, and the runtime can just call into that top level method. It doesn't care about this big group up there. And the same is also true for static extension methods and operators. And now looking at, okay, now I have to move back. Yeah, when you basically use an extension method, that's what you already know and recognize. For extension members, properties, it basically works the same. And yeah. Static extension methods, you can basically just use the, like you would expect. You can, it's a static member on string, so it's fine. And you can also do some Java, Python shenanigans, and you can construct paths via the division operator. That's a nice example. So what does it look like when lowered by the C# compiler? Basically, we're calling into the implementation method. And also for properties, there is no property syntax. Basically, properties are compiled down to get and set method invocations. It's just call instructions. And also static extension methods, just they swap out the type. And yeah, there is a small display bug because this .NET Lab uses ILSpy internally. And as you can see, ILSpy helpfully replaced the operator calls with the actual operators. So I'll just switch over to the IL and show you what it looks like. So it's not me telling you weird stories. It's in fact a op division invocation. Yeah. Next thing is
you will either need to have to cut some architecture stuff or some samples.
Yeah, okay, so then actually, quickly, I'll show you what happens when you actually, so I think I can cut the samples because it's too small anyway, like you cannot see anything, it's, yeah. So then let's switch back to my presentation. Yeah, so I will quickly go over the architecture of our decompiler. That's the big picture. So That's how it works. End of story. Nah, just kidding. I'll explain step by step. Okay. Yeah. So what's actually the input of the decompiler? At its core, it's basically a .NET assembly, and what's in a .NET assembly? There is metadata. Then there is more metadata from referenced assemblies, and there is the IL bytes. And the references may be reference assemblies. So you cannot expect from a decompiler, from the perspective of an assembly consumer, you cannot expect that you actually get the runtime assemblies. And so you actually have to be fine with the things you have, just the metadata and no information about the implementation. So yeah, metadata is really important, and because IL without metadata is useless, it's just bytes. So of course you can decode the bytes and see, okay, this byte means it's a call instruction, and by definition, a call instruction is followed by 4 bytes that contains the token for a method or a method specification. Yeah, I'll not go into details. So to actually know what's going on in a .NET or IL method, you actually have to interpret those numbers, and the metadata stores the information about types and members and references and so on. And managed assemblies are basically just databases. They are write once, read many times databases. And each table has a number, and each row is basically one, like there is the type def table that contains all the type definitions, and each row in that table is basically one type. Then there is many other tables, and you can basically do you can do foreign keys when you combine the table number and the row number. So yeah, 0 to 00001 is the first type definition in the module. If you want to know more, there is a cool talk by David. You can just click on the link in the presentation, and he goes through all the details in more detail. So second step is we actually need to load the metadata. So we're using SRM for that, or System Reflection Metadata. That's a library provided by Microsoft. It's used by Roslyn. It's used by the .NET Runtime. Basically, everyone uses it. And the one really good point about that library is, you may remember monocecil. It's a bit heavy, and System Reflection Metadata allows you to actually access all the tables directly, and it's fast. The problem is there is no convenient API. So if you actually want to put all the stuff into relation or decode the method signatures, you actually have to do most of the work yourself. And it requires some low-level knowledge about how the database works. It's basically like when you know an RDBMS, and there is no SQL and no joins. So basically, it's weird. Around SRM, we basically built our own decompiler type system, which is the high-level representation of metadata. We also have our own syntax tree, and we also have many language-specific stuff implemented, like member lookup, type conversions, and overload resolution. And I have to say that overload resolution in C# is actually the most complex part of the compiler, I would say. I think there is a good reason why Rust doesn't allow method overloads, and they did themselves a favor by not doing overloads, because it's really difficult. Luckily for a decompiler, it doesn't matter. If we don't get overload resolution completely right, we add casts and we're fine. It's ugly, but it works. And the decompiler type system is basically comparable to Roslyn. Yeah. Now we have this C# decompiler class. It's the driver or entry point of our decompiler. So if you want to decompile something, use that. The inputs is basically the decompiler type system and options. So what language version do you want to decompile to? Do you want to leave out the link syntax? Or there are many, many options you can choose from. And it offers basically an API to decompile members and types. And it returns a string or the AST, the abstract syntax tree. And it's basically the driver, so it decides what members should, under the current configuration, be visible when decompiling. For example, in records, most of the members are compiler generated, so we actually want to hide them, but we need to decide which, we need to actually figure out which members to decompile or not. Also, extension blocks, they are created or like inserted at this top level of the decompiler pipeline, yeah. And the first thing is we load the method bodies via the IL reader and we start the transformation pipeline. The first step of the transformation pipeline is IL reader and the block builder. So basically we decode the IL instruction stream and we normalize the instructions because there are some variants of, there are many IL instructions and they usually follow, there are groups and we basically decode all the different variants into one normalized representation. Then we basically construct a statement or it's an expression tree basically that's more similar to C# than to IL because IL is just a sequence of instructions and we build expressions out of that. And we do some inference of types because in IL there is basically just numbers and you need to actually reverse engineer the types for some parts. Then the block builder basically detects basic blocks. A basic block is basically a sequence of instructions that ends in a jump or like in a jump instruction to another block or out of the method. And we also make the implicit conversions explicit where possible because IL is not as strongly typed as C# is. In the second step, we basically build the IL AST. And there the IL AST is basically a structured representation of all the instructions. So it actually looks close to C#, but isn't C#. Every instruction has we have basically not only instructions, but we also have blocks for try blocks, catch blocks, loops, and so on and so forth. And each instruction has its explicit result type. And I'm not going into all the IL AST transforms because the list is really, it's a long list of special cases and stuff we need to do. But the general goal of a transformation at that level is to not change the semantics of the IL code, but just to make it nicer and to actually, So next is after we basically processed the IL fully, then we start building C# code. That's basically, we first build statements, so loops and everything. And for each statement, we then have the expression builder that produces out of our intermediate representation, produces C# expressions, and we convert the IL types to C# types and remove conversions if possible. And the call builder basically is a special case of the expression builder because calls, like I said, overload resolution is a complex topic, and there are so many, I think the most prevalent instruction in C# is actually, I would say, calls happen all the time. So we have a separate call builder, so we get the correct semantics. And that's also where the calls to a property accessor, so the get or set method, are transformed to method calls, to the property syntax, sorry. And because we need to actually ensure that when we decompile the code, basically, if you recompile the code, the decompiled code, it actually needs to go back to the same, it needs to call the same method that was called in IL. So we actually have to re-implement the whole overload resolution that Roslyn does. Then we have a short list of C# transforms. Not all of them are on this slide. And they basically just do smaller beautification. Also, this replacing of the operator method invocation with the operator syntax, the bug I showed you before, is done at this step. So, and we also introduce, we declared the variables, we introduced using declarations, and we introduced the extension method syntax. What's currently not implemented is we don't transform extension members back to their nice syntax. But when we're going to add that, it will be implemented in this as a C# transform, most probably. And we also transform extension method chains to link expression syntax. Yeah. The last thing is, the last thing is how we produce output, and that's basically, we basically take the AST and generate tokens, and then we insert comments, and basically at the end, we get a stream of characters and some extra information for ILSpy that we can display syntax highlighting and tooltips and the hyperlinks. Yeah. And so what is already implemented in ILSpy? We can reconstruct the extension blocks. Not entirely lossless, but that's most of the time you cannot reconstruct everything when decompiling. And the extension operator call sites, they already work. It's a happy little accident, and what's missing is basically that we are not, we don't use the correct, like when you put a static extension method on string, it will still show my extensions dot my static method and not string dot my static method. And this, and we also don't transform the accessor calls correctly, but that's not strictly necessary because your code will compile without, you don't actually need to use extension method syntax to actually use it. It's perfectly fine. I think that's it.
No.
My part,
and you wanted to show one hell of an interesting stack bug as a bonus.
Because you told me to speed up, I sped too fast.
Yeah, so then we switched to 829.
Yeah, okay, so I actually wanted to show, it's here.
So basically, for your information, when a bug in the decompiler is found in Visual Studio, it takes some time that it percolates to us. So then somebody from the Roslyn team comes around and tells us about something that was reported in Roslyn and that we maybe should have a look at something. And that is exactly how that issue came about, that there is a stack overflow when decompiling a long method. And then we started looking into that very long method. And it's in Blazor, so if you're building ASP.NET Blazor and you happen to be using the Fluent UI library, we now have an interesting tidbit for you, if you go switch over. The interesting part is actually on top here, the number of lines and the 1.7 megabytes. And the 1.7 megabytes is basically yield return lines. And 17K of those. So that's how we got into that interesting Stack Overflow exception in here. We were quite surprised when we saw 1.7 megabytes of yield return statements. That kind of was unexpected for our architecture.
Yeah.
And yeah.
Yeah, it's like you can see it's 15,000. That's the line 15,032, and it's still a yield return statement. And quick explanation: why is there a stack overflow? Yeah. Each yield return statement gets compiled down to a state which the decompiler turns into a block. And then we have transformations that work on this block structure. And if you have a sequence of states, that's basically a chain of blocks. And if you go depth first, then 15,000 blocks is 15 levels of stack at the minimum, and so it blows. That's why we had to change the topological sort algorithm to actually use not the stack, but
So basically the message is there is weird code out there.
Yeah.
That's actually in production use. Kind of interesting to see how people are using the language, because we see more or less in the bug reports what kind of obfuscators are being used, what sort of runtimes are still around, the interesting small differences between Mono, then the Xamarin tooling, and versions, like I said, with Roslyn 4.10. So they are changing the lowering all the time. So what happens in the C# compiler from point version to point version is quite interesting to see. So yes, please, if you are building enterprise applications and you are compiling stuff, please compile it once and propagate those build artifacts to all the stages, and don't recompile for every stage, because if there was an patch Tuesday in between, the chances could be that what is being produced for you is no longer the same that you were testing in the dev stage. So please use the same artifacts when propagating to environments. That could be very much interesting otherwise. So kind of free advice. To close out our talk, there is one important number to remember. It's not 42, it's 829. This is our C# feature tracking issue, where you can see which C# features are actually being supported by our decompiler. And our general rule is that we only mark stuff as done when it's done, definition of done. So that's kind of why extension everything, although basically the extension blocks are already decompiling properly, we still have call side work to do, etc., like Sigi pointed out. So that's why it's not marked as done. So it's partially there, but it's not nice the way we want it to be actually in there. And some features you find as a strike through, because it's simply totally impossible to reverse certain features of C#, like nameoff, for example, being a prime example, because nameoff turns a class or something else basically into a string. And how on earth would we know that actually somebody didn't write the string, but actually used the nameoff function? So that's why certain features are simply marked as, we can't do that, sorry. So that's kind of what the feature story here is going on, and some things we intentionally put on the back burner because we also make a decision what is the kind of cool feature most people most likely are going to use in a new version of C#. And so we try to pick off those ones that look like they might be very popular with the developer community, so that ILSpy starts out supporting those and then later on fill in the missing parts of the more esoteric new language features. The 7 series had a couple of those that were mostly interesting for Kestrel and server builders for optimization stuff, like the stack refs and stuff like this. But in general, if you want to know if ILSpy can decompile something successfully, that's your ticket, your place to go to. And yes, if you find something that doesn't work, please tell us. That's how we can improve. So also go here to the issues, open up an issue, and let us know. Otherwise, it won't get any better. So that's kind of the thing. And with that, I would say we head over Shift Tab. So, and thank you for your attention. Thank you for bearing with details you never needed to know in the first place. Maybe it was kind of funny to see what the C# compiler does for you when you're using one of the latest language features in C#. How the lowering kind of does funky stuff, creating all funky things going on for you. And if you have any questions, we will be happy to answer them right now or with drinks. So depending on your need for food and drinks, we can cut the official Q&A short. But thank you very much for your attention. Thank you for coming. Thank you for bearing with us. Any questions? 3, 2, 1. Drinks.
Christoph, I don't know why are you telling them that it's hard to that it's unbearable. I think compilers are fun. You know,
I am going to use a .NET 11 feature to prove my point. Runtime async, the state machine of async await. If you want to sit through a lot of pain, we're going to talk about async await and how it's implemented internally. That's painful.
yes.
So, point proven. Thank you.
All right, I think
and you wanted to kind of close out
time for
the day.
First, thank you both for joining. Thank you
Thank
very
you
much.
very much.
Again, big round of applause to the 2 speakers. Good. 2.